Hi everyone, how are you doing? I hope you are in the pink of your health, you're doing well and ready to have a look at what is here. Four most important problems from Geometry CBSE 10 Part 1. Okay, so geometry is dreaded by many. I am telling you, I used to fear geometry while I was a student of your age. And I believe that's the case with many of us. Why? Because we fear theorems, we fear giving reasons for every applicable step. But I tell you, it is about understanding. Once you understand geometry well, you will fall in so much love that you will keep on practicing on your own, even if nobody has asked you. And do you want to land up into a scenario like that? Like the one that I just discussed, wherein you would want that, okay, I want to master geometry. And if you do so, these four most important problems, if something or the other of this sort comes in the exam, you have full marks, guaranteed. Guaranteed by whom? Guaranteed by me. So who am I? My name is Riddhi, and I am a person who has done my graduation also, post-grad also. So I got a gold medal for my graduation, BTech Computer Science. I also got a gold medal for my MA English, Masters in English Literature. Then I did my B.Ed in order to understand you students very well. With 8 years of teaching experience and being recorded 4,000 plus teaching videos, mentoring more than 6,000 students, I am sitting in front of you to discuss about the four most important problems that you can have in your CBSE paper. Something or this, has been repeatedly asked again and again, and that's how I call this as most important. Right? So, are you excited? If yes, in order to begin the session, if you feel yes, we are excited, just write excited. Yes, write excited in the comments, and you can use as many emojis as you would want to in order to show that you are really super excited for today's session. Wonderful. Thank you so much for the wonderful response. And today's class has what? Today's class has these four, topic-based questions. One is on collinearity. The other is properties of tangents to a circle. Next is area of triangle and sides of triangle relationship. And the last but not the least, parallelogram subscribing a circle. Right? So if you want to note these, pointers down, you can with respect to collinearity, tangents to a circle, area of triangle and sides, and parallelogram circumscribing a circle. So if you see, these are all based on geometry. And if you also see that the topics are not of all the same chapters, right? So we have tangents to a circle and parallelogram circumscribing a circle related to circles, while area of triangle and sides is of a different chapter altogether. Collinearity talks about coordinate geometry. So you have to understand that in your exam also, there will be just questions. Will there be a chapter name disclosed towards the end for every question? Or just towards the, adjacent side that, okay, this question belongs to this chapter? Does it ever happen? No. So you have to be prepared with the whole of the syllabi and not be dependent on one chapter's name that will come in order to begin. Did we get this point very clear in our head? Yes? Okay. So the first concept is what? Collinearity. Now, any idea about what is collinearity? Any responses that I may get from your side onto collinearity? Meanwhile, I have, a sip of water. Yes. What is collinearity? So, one thing that you should know while you see it here. Do we find something written here? And what is it? The one that I'm just shading, only that part. Linear, right? And if I don't even shade AR, if I just forget this AR thing also, and now if I just shade something till here, what do you think am I shading? It is line. So that means we are talking about being in the same straight line. That's collinearity. All combined, you see, in a same straight line. Got it? So here is a very interesting question just based on this topic. It's very important to understand maths not only through theories but also through appropriate, you know, what say, questions, right? Because implementation is more important. So find the relation between x and y if the points this are collinear. So there are 3 points and we have to check for collinearity. In order to check for collinearity, understand that if there are 3 points a, b and c, right? So a, b and c are collinear if they lie in the same straight line. Yes. So since they are on the same straight line, what do you think? What about the area of triangle that these 3 points will form? By area of triangle will be what? 0, because actually there will be no triangle formed only. Isn't it? No triangle will be formed because they are on the same straight line. So, in order to check for collinearity, the best part is you write the area of triangle formula and you equate it to equal to 0, because there is surety that no triangle will be formed, right? So, what is the formula of area of triangle? Half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. Got it? So what are these x1, y1, etc.? So this is your x1, this is your y1, this is your x2, this is your y2, this is your x3, this is your y3. Right? So we will use this formula. The first step is you write that. Now, since it is given A, B, C are collinear, what do? You straight away do something. And that something is you solve further. How do you solve further? You put this equal to 0. So half, let's substitute the values. What is x1? X. y2 minus y3 is what? 7 minus 5. So I will just like 7 minus 5 directly is 2. Got it? Plus x2. What is x2? Minus 5. What is y3 minus y1? 5 minus y1. So 5 minus y. Plus, what is x3? Minus 4. What is y1 minus y2? y1 is y minus y2 minus 7. And this all is equal to 0. Do we all agree to this? Yes or no? Do we all agree to this? Yes or no? Yes, we do. Right, great. Now, let's see, to solve further. So half, it was x into 2, which is 2x. Then it was what? Then it was, if you see the step behind, so minus 25 plus 5y, right? So minus 25 plus 5y. If you go further behind, minus 4 into y is minus 4y, minus minus plus. So minus 4y plus 28 is equal to 0. This 2 goes there, right? So we are left with 2x minus 25, 4y, 5y when you solve, plus minus minus this, plus 28 is equal to 0. So 2x plus y minus 25 plus 28 is plus 3 is equal to 0. So this is the required relation. Okay, because we don't know anything in order to solve it further, you will not be able to get values of x and y. But yes, you will come to this required relation, which was asked. Find the relation between x and y if the points are collinear. I hope you understood. If you did, please write yes. Great. Okay, so let's move ahead. Yes, let's move ahead and see the further thing. Okay, so the next topic is what? Tangents to a circle. Now, can anyone tell me what is a tangent through your comments? What is a tangent? What do you think is a tangent? Okay, so basically a circle is this, right? And you might have seen some figures in your book where something is written like this. Probably like this, and this is. So what is this? This is nothing but a tangent. So a tangent intersects the circle here at just one point. It touches that at one point. Okay. So here we will find a question which is, very frequently, it has been very frequently asked. The values might change in the paper, but this kind of a question is very interesting to use. You should know this question, nothing should be missed from here. Okay, so let's see this kind of a question. What is it? Now, if you see in the given figure, a circle is inscribed in a triangle ABC. It touches the sides AB, BC, AC at points D, E, F respectively. I repeat. The given figure is there, circle is there, touches. So if circle is inscribed means circle is inside the triangle, right? Touching is there at 3 points F, E and D, or in, the literal order it is D, E, F respectively. Okay, so just forget this K, that's something not relevant, it's incorrect. If AB is equal to 12 centimeter, BC is equal to 8 centimeter, AC is equal to 10, that's already marked in the figure. Find the length. So you have to find the length of this much part AD, this much part BE and this much part CF. Got it? Now understand that you will have to use a theorem in order to solve it. And what theorem will it be? Any guesses? Any guesses what theorem should it be? Yes? What do you think should be the theorem used? It is related to tangents, you're all right, but what is the exact theorem? See, in theorems in maths and definitions in science should not be messed up. You should remember in maths the theorems word by word. Just like in formula, we don't write pi r square ko pi into 2r just by our own wish and will. So here also that should not be there. So it is, I will tell you, length of tangents drawn from an external point to a circle are equal. That means if there is this circle and if there is one point A and there are two tangents drawn, one like this, the other like this, forget this intersection and all my bad handwriting and diagram skills. So the length of the tangents, these two will be equal. So AB and AC will be equal because they are drawn from one single point and towards the same circle they are targeted. Got it. So now if you see, let us name these piecewise because we know that with this principle or with this theorem, if you see A is an external point, so AF should be equal to AD. Similarly, CF should be equal to CE and similarly BE should be equal to BE. How many of you agree with this logic? Yes, so since they are equal, we will avoid writing AD, AF, this, that again and again. Rather we substitute with X, Y, Z. Will that not be easier for us to understand? So yes, what I will do is I will write let AF is equal to AD is equal to X. Let this and this be your Y and let, tell me. Wonderful. Let this and this be your Z. How many of you agree? So this is how you will write here. AD is equal to AF is equal to X and rest you can write on your own. I'm waiting. Write it on your own. What will you write? DB is equal to BF or BD is equal to, sorry, BE. BD is equal to BE and CF is equal to C. Let's wait for you to write. Very good. Right? Everybody written? Shallow. Let's move ahead. Now what to do? Now we already have this as X and X. This was your Z and Z and this was your Y and Y. Don't you think that X plus Y is becoming 12? Don't you think as per the figure X plus Z is becoming 10? And don't you think as per the figure Y plus Z is becoming 8? And now what do you have to do? Now you have to find out the unknowns. And the unknowns are what in this case? All X, Y, Z. Right? Because AD we wanted AD is X, BE wanted BE is Y and CF is Z. So if you want X, Y, Z, what you will do? You will simply first add all these equations. If you add all these equations, what will happen? You will have 2x plus 2y plus 2z, right? So let us add all the equations, equation number 1, 2 and 3. So you have 2x plus y plus z, right? So that is equal to 12 plus 10 is 22 plus 8, which is 30. So that means x plus y plus z is equal to 15. Right? But now it is all in x, y, and z. So what can we do? We can solve two of the equations together. So if you solve 1 and 4 first, take 1 and 4, what will happen is x plus y plus z minus x plus y is equal to 15 minus 12, which is 3. And this gives you z, isn't it? Similarly, in order to find the other unknowns, now you have already z, you can put that value of z in equation number 2. So x plus 3 is equal to 10. So that means x is equal to 7. This was your equation number 2. Now you have x, now you have z. What do you not have? You have a problem. That is, you don't have y yet. No problem at all. You already have x is equal to 7. Put that in equation number 1. So, in order to solve further, put in equation number 1. What? That x is equal to 7. So, 7 plus y, right? What was equation number 1? X plus y is equal to 12. So 7 plus y is equal to 12. So that means y is equal to 5. So these are all your 5 answers, right? 7, 5 and 3 in terms of x, y and z, right? Now you can cross check. And in the exam, if there are ways wherein you can cross check, nothing like that. So that you are sure that your answer is correct and you have marks secured for it. Until and unless you have not written the theorem and all and your marks get deducted. Got it? So here if you see x plus y is 12. So here anyways we already saw that this was x and this was y. X plus y is 12. And this was also x and this was your z. So now what should be your x plus z? 10. Is x plus z 10? Yes. Come here. Now this is your z, this is your y. Z plus y should be 8. Is z plus y 8? Yes. So your answers are all correct and these are all in centimeters. Do not forget. So these are the required lengths. Now the question was AD's length is what? AD is equal to x is equal to 7 centimeter. BD's length is what? What? BD is equal to y is equal to and this is equal to z is equal to. So you write yourself in centimeters and let me know if you've understood. How many of you understood? Say yes or type yes. Very nice. Okay, let's move ahead. Right? Area of triangle and sides of triangle relationship. So we all know area of triangle is usually calculated either by Heron's formula if the sides are not, if the triangle is not a right angle triangle. And the sides of the triangle means the dimensions. So is there a relationship between the area of triangle and the sides of triangle? That we are going to see here. Yes, there is one, and there is also a question that we have in front of you. Can you read this yourself first? Slowly read this yourself. Please. Yes. What do you think? Is it based on? What do you think is this based on? So it says the sides AB and AC of triangle ABC. So let us make a triangle ABC. And with perimeter P are respectively 3 times the corresponding sides. Okay, so this should have been bigger though. Okay, it should appear as 3 times now. Are 3 times corresponding sides of triangle DEF. Are the two triangles similar? Find the ratio of the area of the two sides. Okay. So see, there are two parts to this question. One is that you have to talk about similarity and the other is you also have to talk about the ratio of areas. Right? So here if you see sides AB respectively corresponding side DE. So AB and we are talking about DE together. Similarly, we are talking about AC and DF together. And we are talking about what? We are talking about the ratio 3 times. So they are all 3. Did we get this? Ratio is given of the sides corresponding to triangle DEF. So we have taken it that way. And if this is there, if two pairs of a triangle have corresponding sides as a ratio given, so we can also see that here this will also be applicable, right? So if this is happening, don't you think these two triangles, triangle ABC is similar to triangle DEF? And by what criterion? We are not talking about angles anyhow. So we are talking about just the sides. So that's why it is triple S criterion. Side, 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 criterion of similarity. Right? So you must be thinking that this is all related to similarity. How this topic is then area of triangle and sides of triangle? Wait. Sides of triangle thing we have already done, and that's how areas relation has already come. Because we know a theorem, and that theorem talks about something. And what is that something? That theorem talks about the fact that if two triangles are similar, then the ratio of their areas is calculated how? The ratio of this areas is calculated this way. The corresponding sides you take, and you take their square. This is how you will get the areas ratio. This is area of similar triangles. Two similar triangles, when taken, the ratio of their areas is equal to the square of corresponding sides, square of ratio of the corresponding sides. So what was AB upon DE? What did we know? That AB upon DE we directly saw here was 3. So that is why this is also 3 square, or 3 upon 1 square, which is nothing but 9:1, and that's your ratio required, 9:1. If you say, are the two triangles similar? Yes. And find the ratio, 9:1. Have you all understood? And can we proceed to the next topic, which is parallelogram subscribing a circle? And can you guess the meaning of subscribing? Because we have already seen the meaning of inscribe. Did we not see the meaning of inscribe? What do you think is the meaning of circumscribe now? Please tell me. Yes. And how do you identify a parallelogram? Are there any traits that, okay, this is a parallelogram? Circle is anyways goal, na? Circle is this way, like a ball. If you talk about a 2D thing, obviously ball would be a sphere, but circle is that. How about a parallelogram? Is this mobile phone that I might have a parallelogram? So parallelogram, as the name suggests, has opposite sides parallel. Okay. When I say parallel, that means even if you move ahead, they will never intersect. Got it? So now see this. Prove that parallelogram subscribing a circle is a rhombus. So here technically you feel that there are three quadrilaterals or three geometrical figures talked about, and this is very confusing. But my dear friends, wait. This is not as confusing as you are hyping it as to be confusing. Okay. So see, rhombus is there, parallelogram is there, circle is there. Parallelogram is circumscribing a circle, means parallelogram is outside the circle. Had it been inscribing, it would be inside. So parallelogram is outside a circle. So inside is a circle, right? We saw that we have to draw a relevant figure, and that's how we are drawing a relevant figure. So inside is a circle and outside is a parallelogram, just circumscribing it. So very carefully draw a relevant figure, right? Now if you see, this is, by mistake it has gone up. So please delete this. This is not going to be there. Let's name it as A, B, C, D. So now A, B, C, D is your parallelogram that we have considered. Circle is anyways inside, so you identify it. And it is said that any parallelogram that's outside the circle, circumscribing the circle, has to be a rhombus. Now, what is a rhombus? So, with respect to a rhombus, that's a special kind of parallelogram with all its sides equal. Now, you will say that, ma'am, in a square also all the sides are equal. So, why we are talking about a rhombus? So, in a square, all angles are 90° also here. In a rhombus, it can even look like this, with all sides equal, and then that's it. It will become a rhombus. Forget about 90° thing. Okay. So if you prove somehow that AB is equal to BC is equal to CD is equal to DA, your work is done. Got it? Okay. So the first step is to draw a relevant figure, which we already did. Let's move to the second step. In order to understand the solving purpose, which theorem should one use? Or do we even need to use a theorem, or just add the equations directly? right? We will see that. Now, if you see, let's see the figure previously again. Here, if you see, don't you think that, here, these are the points of intersection? They are. Can we not name it as PQRS? Any trouble if I name it as PQRS or not LMNOP, whatever? No, right? Now just check this B point. From the B point, we have 1, 2. From this C, we have this and this. From this D, we have this and this. And from this A, we have this and this. So don't you think these are external points from where tangents are drawn? And don't we think that we can use the theorem length of tangents drawn from an external point to a circle are equal? Yes, we can certainly use it. Now what to do? Now very simple. Very simple. Just make equations, just add equations. Okay, so I will very quickly draw this again for you. It was a circle and it was, sorry, this was point P, Q, R and S and A and B and C and D. Now, if you see that here AB is equal to CD. Why? Why? Because it is a parallelogram, so opposite sides are equal. So AB is equal to CD and BC is equal to AD. Is that a problem? Is there a problem if I do this? No. These are equations number 1 and 2. Now, because of the theorem that we just saw, we will have dr is equal to ds, right? From an external point D. Cr is equal to CQ, right? Your BP is equal to BQ, right? And your AP is equal to AS. Got it or not? Now, these 4 are there. Can we not add these? Yes, we can certainly add. So we have dr plus cr plus bp plus ap. Left hand sides you add, and then you add right hand sides. ds plus cq plus bq plus as. Is there a problem here? No. Now, what is dr plus cr? It is whole of your dc. What is bp plus ap? So bp plus ap is whole of your ab. Isn't it? What is ds plus CQ? Not getting anything. What is BQ plus AS? BQ plus AS. Again, not getting anything. So in this case, what to do? Now, ds is equal to dr, we know. Isn't it? Or no? Are tell me, isn't it or no? Right. So here, if you see, your left hand sides are sorted, CD and AB. In right hand side, we need AD and BC somehow. So if it is AD, it should be AS plus DS. So DS is already there, right? Somehow I need AS. Now, how to get AS is the question. Can you write a way wherein we can get AS? I'll wait for your response. Please write a way wherein we can get AS. I will tell you. It is already there in front of you. DS and AS can you club? DS plus AS is AD and CQ plus BQ if you club, that's nothing but BC. And don't you think we have got till here? AB plus DC is equal to AD plus BC. Now, from equation number 1 and from equation number 2, you have something that AB is equal to CD. So, here can you not write twice of AB? Because AB is equal to CD. And similarly, AD and BC are equal. So can you not write twice of AD? Right? Now, can you not divide this whole by 2? So AB is equal to AD. Can you not get this? Now, AB and AD being equal, similarly, if AB is equal, see. Okay, so this is your equation number 3. So if AB is equal to AD from 3, if AB is equal to CD from here, so can you not say AB is equal to CD is equal to AD? And then here also BC. So can you not say all four sides are equal, my dear friends? Yes. So before moving to the summary, we have got the fact that AB is equal to BC is equal to DC is equal to AD. That means your ABCD is a rhombus. So hence it is proved that a parallelogram subscribing a circle is a rhombus. How many of you understood, yes or no? Right, and if you like today's session, you must check the summary. What did we read? What did we study? We solved a question based on collinearity. Col means together. Linear means line. So therefore, collinear points means together on a straight line. Right? We use the area of triangle concept and put it equal to 0. Question based on properties of tangent. So there are different properties of tangent. These all three you should know. Any question can come on any of these properties. Tangent to a circle is always perpendicular. So for example, this is a circle, this is a tangent. So so this is one scenario, and the tangent can also be here. So here this is your 90 degree, right? And here also, if you join, it will be 90 degree. Chord and a tangent form an angle. This angle is formed at the tangent subscribing opposite side of the chord. So okay, so here at times this is same external point, length of the tangents are equal. So this is one scenario. This one, the third one. Then we are also talking about a chord and a tangent. Okay, so here there can be a there can be a chord. All this can also happen. So you will have to check for the figures and then understand which theorem applies. Then area of triangle and side relationship. If similar triangles are there, ratio of area of both the triangles is proportional to the square of ratio of their corresponding sides, right? So for example, area of triangle 1, area of triangle 2 is equal to, suppose it has side AB, it has side DE, so AB upon DE whole square, something like that, right? And here also we saw a question based on this theorem wherein we actually proved only this theorem, that parallelogram subscribing a circle is a rhombus, right? So this is how you do kind of questions. If you have any doubts, you can ask in the comments. Any doubts that you all bacha log might have can ask in the comments. I'll stay for another 2-3 minutes. Yes. Is there anything? Chalo bache. ठीक है. I really thank you all for being a part of today's session. See, this session is something which I feel you should watch it again and again if possible. Right? Because you are going to learn a lot from this. These many questions are not only important, but the topics that we entertain, please practice questions based on this. All topics are important, and wish you all the very best for your preparation. Thank you. From my side, my name is Riddhi. God bless you. Let's meet in the next session.